You see, problem 1, benefit cost analysis. A new bypass is being considered by the local highway district. The project costing 4 million to build. So this basically the initial cost. And we'll provide the estimated annual benefit. So keyword here, that is the annual benefits. 125,000 to local business. The annual cost of maintenance is 200,000. If the life of the bypass is 20 years and an interest rate of 8% per year is used, determine the B/C ratio for this project. And the life of the bypass is 20 years. We have interest rate, we did the MAR. And always we start with the draw the cash flow diagram for this one. So let's draw the cash flow diagram for 20 years. So the time scale is years and for 20 years. So we have here years started now, so time 0 for 20 years, then 20, 5, 15, 20 years. So the costing 4 million to build and cost going down, so that down 4 million to build, 4 million. The benefit 125,000 annual benefits, so it's same amount. Benefit every year, so that the annuity A. And this is 125,000 per year. Annual cost for maintenance 200,000. So costs going down and annual, so it happen every year with the operation and maintenance. And this is 200,000 per year. So for 1,000, I put K in there. So as you can see, it always we talk about the equivalence regardless which method we use. So it have to be compare the money at the same time or in the same uniform annuity. So there are two ways that you can do. You can print the annual amount 225,000 per year to present time, which is present value at time 0, and the operation and maintenance cost 200,000 per year to time 0 to have the present value of the maintenance cost, and then we compare at the present value with the ratio that we learned in benefits cost analysis previously. So we have that one here, the equation for conventional method here, and of course our modified benefit cost analysis. So let's go back to here, to this problem. For here, I use the annual values at the common unit basics instead of put at time 0, that you can try print 200,000 to time 0, 125,000 time 0. So given A 5P, given A 5P, and compare benefit. So the equivalent present value of 225,000 per year at time 0 with the cost, including the initial cost at time 0, 4 million, and the 200,000 here bring back to time zero, that is the operation and maintenance cost equivalent at present value, so that you can do that. But here I use the annual values at the common units basics to compare. So here use annual value, so uniform amount at the common unit basics. And with that, I bring everything to the annual amount. We already know the benefit is annual value already, 125,000 per year. So what we have here is the benefit in this case. We already know that is 125,000 per year, and the operation and maintenance cost. So we have O and M cost, and in this case O and M cost is 200,000 per year. And then we need to print the 4 million initial cost, the investment cost, to the annual values. So given P phi A, so we have that in the initial cost so we have 4 million dollar. $4 million, and that is present value. We want to print that in annual amount. So given P phi A, so we can have the factor A relative to P with the MAR. The problem gives us 8% interest, and for 20 years. So basically we distributed equivalent amount 4 million at time zero. How that equivalent to annual amount? And with that we can use the table, and by now you can be able to use the table, and I just put the number here, use the table in the reference. So that A over P 8% 20 is equal to 0.1019. So it equal to 400 4 million times 0.10119, and that from the reference. So we get this one equal to 407,600, and this is annual amount per year. So basically this one, the initial cost, the equivalent of $4 million spent at time zero. equivalent to you spend 407,600 per year for 20 years. Then from that we can apply the benefit cost ratio. So we have two ratio that we have it previously. So we have the conventional B over C, and the equation is the benefit, subtract this benefits to the cost. And the problem don't give us the this benefit in this problem, so it's 0. So we can have the benefit 125,000 per year minus this benefits 0. For the costs, is including by definition in the first videos, it including initial cost and operation and maintenance cost with here the annual amount as you can see. So the initial cost is 407.6k, and you can see the equivalent amount plus the O&M cost 200,000 per year, so 200,000. So this one we will get the ratio 0.206, and it's less than 1, and you can see there less than 1. So what we can say, if it's less than 1, we can say that it's not financially viable. So we can say not viable. So this project is not viable. So even you see without doing this, we already know, and you can see benefit only 125,000 per year, the cost 200,000. So it's not even the benefit is not does not enough to cover the O&M cost, let alone cover the initial cost. That's why obviously without doing the calculation you can do the common sense and see that it's not viable. But this to apply with the method, so you can see have it in there. And then we can have modified B over C. B over C, and that equal to the equation benefits minus this benefit minus O&M cost. So the cost of the O&M going up there, and of course we divide the initial cost here there. Other costs, any other cost minus service value. So that one we can plug in 125,000. This benefits 0. O&M cost we have 200,000 per year, divide by the cost. In this case only initial cost, because we already count the O&M cost on the numerator, so the denominator is only the leftover 400.6k, and you can see there. So from that we can have this equal to is a negative number, negative 0.184, and of course both methods should have the same answer. Both methods should have the same answer. So with that, this ratio, you see it less than 1 because that is 1.84. That's not 1, so it's not viable. So that will be answer with the benefit cost analysis. And again, we can use benefit cost analysis to compare the alternative, but we have to use the challenger and defender concept. And you should to practice that in the additional practice problem in today's class.